Are we alone in space or not? With the current level of knowledge about space and biology, the answers will be speculative. Despite this, a scientist is more likely to be inclined to the answer no, because science basically looks at all processes systematically and is guided by a probabilistic approach. 3 or 4 billion years ago, the first replicator appeared on Earth. It is a molecule similar to DNA in the cells of our body. The main characteristic of life is self-copying. A replicator molecule is both a matrix and a printing press, which produces its copies from available chemical elements. With the advent of the replicator, there was the potential to create not only cells, but also their clusters, and from there multicellular organisms, like you and me. The question of the appearance of a replicator is interesting in itself, but we are now interested in how common its occurrence is on planetary systems. The probability of an accidental occurrence of a replicator just like that, out of nothing, is non-zero. According to the calculations of astrophysicists, there are 100 billion habitable planets in the universe. There is a fact that life has already originated on Earth. That is, a replicator did appear on one of these planets. Then the probability of life would be 1 in 100 billion, and that would be enough to settle down. But this is a very superficial answer. In addition, we cannot land on each of these planets and carefully study its surface in search of replicators, and we have already realized that the presence of a replicator means the presence of life. Watching the beauty on a dark, clear night, you can get lost in the night sky. However, we see only a small part of what is there. Based on the effect of its mass on neighboring objects, it is estimated that the Milky Way contains from 100 to 400 billion stars. Until the early 20s, it was believed that our galaxy was the only one in the universe. Today it is becoming clear that our galaxy is one of billions. She's not remarkable. On a larger scale, it's not even noticeable. It's part of the universe. Well, let's get away from all this. One galaxy is more than enough for our purposes. Let's be conservative and assume that there are only 200 billion stars in our galaxy. To date, 638 planets have been confirmed and another 147 candidates are awaiting confirmation. The more scientists search, the more they find. It is estimated that there may be up to 6 billion Earth-like planets in the Milky Way galaxy. This assessment should be taken with a grain of salt. It is extrapolated from a relatively small number of observations. The assessment of Earth-like is limited to life as we know it. It is assumed that we understand well both the mechanisms of planet formation and the requirements for the development of life. Both assumptions are questionable. But consider this number. And let's take into account that without technological breakthroughs, it may be possible to reach other stars during the lifetime of a human crew. When we can achieve one, we can achieve the others. Growth can be exponential. And if we can do it, others can too. Our signals are already reaching the nearest stars, and others have been around much longer than we have. This is the root of the so-called Fermi paradox, a question raised by physicist Enrico Fermi in a casual conversation among physicists in 1950. They were offered dozens of explanations for the Great Silence. You can't answer a question if you don't know what you don't know. In 1961, Frank Drake tried to evaluate the various factors involved in assessing the probabilities of contact with extraterrestrial life. This became known as the Drake equation, where there are many unknowns. Some consider technological civilization to be a self-destructive experiment. We definitely had problems with her, which would explain why no one contacted us. However, recent research suggests a more intriguing possibility. Planetary scientists Robert Stern from the University of Texas at Dallas and Taras Jaya from Zurich suggest that the presence of both continents and oceans, as well as long-term plate tectonics, are crucial for the emergence of advanced civilizations. They suggest adding two factors to the equation: the proportion of habitable planets with significant continents and oceans, and the proportion of these planets with plate tectonics active for at least 500 million years. The researchers claim that large oceans and the Earth's transition from single-layer tectonics to modern plate tectonics about 1 billion years ago were critically important for the development of complex life. This geological activity created the initial conditions necessary for the emergence of life and led to diverse environments with different climates and ecosystems, which contributed to the evolution of advanced life forms capable of developing technology and complex societies. The movement of the Earth's plates creates diverse habitats, recycles nutrients, and regulates the climate, all of which are vital to life. It is important that this plate tectonics last 500 million years because the evolution of complex multicellular life is extremely slow. Technology appears very late in the process, responding to everyday needs such as tool making, agriculture, clothing, and weapons. Fire is a necessary condition, so technological civilizations will not arise in strictly oceanic environments. On Earth, dolphins and whales are intelligent, social creatures. but none of them went beyond the sea, let alone the stars. Scientists have studied how much water is needed on the surface of the planet. They found that an Earth-sized planet needs to have from 0 as much as 0.07% to 0 as much as 0.27% of its mass in the form of water in order for both continents and oceans to exist. They then compared this to the possible range of water that planets can have, which ranges from 0 to 3.8% or even 0 to 55%, depending on the details of their formation. Scientists have found that only about 33% of the planets have the right chemical elements to form sufficiently dense plates for plate tectonics. Of these, only about half have enough gravity to make it work. Given these new factors and estimates, the researchers concluded that the chance of a planet having continents, oceans, and long-term plate tectonics is very small, less than 0.2%. To put this in perspective, it's like finding just 2 planets that are suitable in size and temperature, which are really Earth-like out of everyone or other suitable worlds. Substituting this value into the Drake equation suggests that advanced civilizations are extremely rare. The chance that the planets have the right conditions ranges from 0 as much as 34/10,000 to 0 as much as 0.17%. This means that there may be only 0 as many as 6,000 or 100,000 active communicating civilizations in our galaxy, most likely closer to the lower limit. If we even have neighbors, they are very far away. This is bad news. The good news is that the chances of finding planets potentially suitable for civilizations, but without any civilizations or with already extinct civilizations, are noticeably higher. Since the low estimate is so close to 0, there is a high probability that there may not be other civilizations in our galaxy. That would help explain why we haven't found any signs yet. Previously, the Drake equation gave a significantly higher lower estimate, suggesting that we are almost certainly not alone and that there must be at least 200 civilizations trying to contact us. The new estimate, which is close to 0, makes it clearer why we have not yet heard from anyone that there is no one else in the universe. Moreover, the Drake equation in its current form, even taking into account new factors, still does not take into account the fact that the Milky Way is incredibly ancient and was probably able to support life for up to 10 billion years. Even with a small chance, intelligent life probably originated earlier in the history of the galaxy, which gave it time to spread. However, we do not see any evidence of this. To summarize what has been said, it is difficult to give an accurate estimate of the number of habitable planets in the universe. Surely life is especially intelligent, one that would enjoy the relative stability of existence for billions of years and not be shaken by any catastrophe. Such a life should be very rare. And that is why our civilization today has a great responsibility for its future. We have nowhere to look for a guide. The dark cosmos is silent and lives according to the cold laws of the birth and death of stars.